Hey folks, welcome to semester two. The chapter with which we begin here in semester two is the lists chapter. This is another example of a data structure in Python. Um, it's very much like a string, though, with more power. Lists, like strings, are sequences of objects, but what distinguishes a list is that it can be a sequence of objects of any type at all, even of different types within a single list. Whereas in the case of a string, we always had a list simply of, a sequence of simply characters. So much of what I'll say about lists initially will be familiar to you already because this is sort of the basic Python syntax for how we handle a sequence of objects. But we'll find as we work our way through the chapter that lists are actually much more powerful than the strings are. So what is a list? Well, I mentioned that a moment ago. A list is just simply a sequence of objects. And when I say sequence, I mean that it has an order. We have an initial element and then one after, and so on until we reach the end. And like I said, lists can contain objects of any type. So ints, floats, strings, booleans, other lists, even functions. Functions are perfectly good object types in Python, and we'll actually see later on where we place functions into a list. So let's create some lists. We'll just work in the console today. So just to prove that Python does actually recognize the basic syntax for list formation, let's create a list. We start with an open square bracket, and then inside of that we place objects separated by parentheses. So I started with the int1, and then the float 1.0, and then how about, I don't know, two booleans, and then how about a string? So how about just spam, since this is Python, of course. And then just to prove that we can do it, let's put another list inside this list as an element within it. Lists are themselves perfectly good objects, so we can put them inside of other lists. So I don't know, how about the list that just contains the initial set of primes, 2 and 3 and 5 and 7? Okay, so we have the closed square bracket for that member list of the outer list, as it were, and then we have the closed square bracket that that ends up the list that we first began with a square bracket all the way over to the left. And then if we hit return, Python repeats back to us the list that we created, which of course lets us know that Python does actually recognize this object that we've created. Now, let's talk about how it is that we would extract elements out of a list, because of course a list would be of little value to us if we couldn't take the elements out that we had put in. So let's give a name to this list. I'll keep it simple. I'll just simply call it capital L. I'm sure I've mentioned often capital letters and variables are used to designate sequence type objects, strings or lists or whatever they happen to be. So there it is. L will be that list that we created. And so the variable assignment took place. Python didn't complain at all about that. And if we wanted to view that list that we created, we could simply type the variable name into the console, and there it is. Now, as for the question how we extract elements out of a list, it's very much like what we did for strings. We use the index operator. And here's how we access that index operator. We first of all type an expression whose value is a list. In this case, it's the variable L. And then we place after that an open square bracket. Now, this is a very different use of the open and closed square bracket than what we have when we create a list. This allows us to go into a list, or a string as well, and extract elements from it. That's why I call it the index operator, because we will actually use the indices of the elements to extract them from the original list. Now, as you know from our study of strings, the initial element of any kind of a sequence in Python always has index 0, and then after that is index 1, and so on, until we reach the end of the list. So if we wish to extract the initial element of the list, it would be L followed by 0 in square brackets, and there it is, the integer 1. If we wanted the element after, that would be 1, and then 2, and then 3. We'll extract them all one after the next. And then 4, give us the string spam, and then 5 is that sub list within the original list. So there it is, the list 2, 3, 5, 7. And then just to remind you of what happens if you attempt to go past the end of the list, I'll use index 6. We get the dreaded index out of range error. Do not be dismayed if you get this error at some point along the way. We all do. Just know that if you get this error, what's happened is that you've used an index somehow that takes you past the end of the list. Now, we can also use negative indices if we like, which is quite convenient in some instances. as I suspect you recall in the case of strings, if you use negative indices, what you do is you start at the end of the list and work to the left. And that final element of the list always has index -1. So L with index -1 should be that sublist 2357. There it is. With index -2 should be the string spam. With -3 should be the element before spam, which was the Boolean false, and so on. So there it is, the use of indices to extract particular elements. Now, there's another way to extract elements from a list that also uses the square bracket, but operates differently in a certain regard. Notice that when we place a single number inside those square brackets, the object that is returned, its type, is just whatever the type of the object of that index is. So L and then 0 returned an object of integer type, L and 1 returned an object of float type, and so on. However, what we're about to do is to extract subsequences, that is sublists, which will comprise typically multiple elements, and the type return will always be itself a list. So let's create one of these. The way you do it is with the square bracket operator as before, and then you'll also make use of the colon. Okay, so there it is, the colon. And then what we place before and after the colon are start first, and then stop values. So let's try a 1 and a 4. And then think with me back to the range function. You know how start and stop values work, right? You actually do start with a start value, but you don't allow yourself to reach the stop value. You end before you reach it. So what that means is that we're about to get a sublist, a list type object, and the initial element in that sublist that will be returned is the element in index 1 in the original list L, and then we'll also get the element in index 2, and then the element in index 3, and then we will stop because we do not allow ourselves to reach or to exceed the stop value. So we should get 1.0, true, and false. Yes, and there it is. And notice that the object type that was returned is another list. These are called slices, and slices are always lists. Now, if you wish, you can put a third value in as well, and that third value is, you should likely guess, will be a step value, just like in the case of the range function. So we'll have start and stop and step. And if we made the step value 2, what that means is that, well, we'll start at index 1, and then we'll skip 2 and pull then the element at index 3. And then at that point, we would have to stop because the next element would be the one with index 5, but that exceeds the stop value, so we don't get that one. Okay, so there it is. If you look back at the original list, 1.0 is the element with index 1, and then we skip forward 2, which means that we got the Boolean false, and then, like I said, we're done. Okay, so you could extract a single element with square brackets, but you can also use the colon inside of square brackets to extract a sublist, that is, a slice. Now, let's look at a couple of particular slices that are actually, in certain contexts, quite helpful to us, and let's see if we can puzzle out what these would be. So the first one is where you simply place a colon with nothing in front and nothing behind. Well, now what would that be? Okay, what would that be? Well, we know about this. We've seen Python allow us to do such things before. When you don't actually supply a value, Python supplies the value for you, and it supplies a default value. If you do not place an element before the colon, that initial element, the one before the colon, defaults to 0. And if you don't place one after, it defaults to the index that will take you through the end of the list. So L, simply with a colon inside of brackets after, returns the entire list. What it did is it copied the list. So that's how we copy a list. And there will be contexts later on where we'll want to actually create a copy of a list. Now, let's look at another, perhaps somewhat mysterious slice. Where we have double colon and then a -1. Well, the double colon indicates that we have all 3 possible values that we can use in a slice, which will be start and stop and step. So that -1 represents a step value. And when we say -1, that means that we move from right to left instead of left to right. So what this slice is the slice that starts at the end of the list and then goes to the left until it reaches the initial element of the list. And so what this particular slice does is it reverses the list. Okay, so we've seen 2, I'm sure would seem initially mysterious slices, but actually they're quite straightforward what they do. One simply produces a copy of the original list, and the other uh, reverses the list. And next time we'll actually talk about some built-in functions that are extremely useful in use with lists. One is the length function, another is the end function, and then we'll actually begin to write a little bit of code that shows just how powerful lists can be.